modulus inequation. So solve for x. We have a modulus inequation here which has two expressions with modulus signs, and well, to solve it there is no way to use any simple tricks available when solving one modulus equations or two modulus equations. Here we have two moduli there, and we have an expression without modulus, and therefore we are in trouble, and therefore we need to use the proper method of zeros, and the method consisting in replacement of expressions with modulus signs by expressions without such signs. So let us do it using the first method, method 1. It's the algebraic method in which we replace expressions with modulus by expressions without modulus. The second method I'm going to show you later is the graphical method in GeoGebra. Okay, so let me start by copying this. So it's 4x minus 8 in modulus signs minus x minus 5, like this. This is less than or equal to 2x plus 8. So this is the inequation. Now it has two modulus expressions. This one has the interior of 4x minus 8, and its zero is obtained by demanding that 4x minus 8 equals 0. And therefore, if I add 8 to both sides, I get 4x equals 8, and if I divide by 4, I get x equals 8 divided by 4 is just 2. Okay, so the zero of the first expression is 2. The second expression with modulus, this one, has the interior of x minus 5, so we obtain its zero by demanding that x minus 5 is 0, and hence by adding 5 to both sides I get that I get the answer, that the zero value of 5. Okay, so we have two zero values, 2 and 5. Now I'm going to place them on the number line. So this is the number line for x values. The number 2 is to the left, and number 5, which is greater, is to the right. So these two numbers divide the number line into three intervals. The first interval is from negative infinity to 2, open at the right hand side. The second one is from 2 to 5, like this, and the last one is from 5 to positive infinity. Okay, and on each of those intervals we are going to solve this inequation separately, and then finding the solutions on all these three intervals we are going to unite them into one final answer. So this is what we are going to do. Now let me prepare a wide table. The table I'm going to use is, well, it's necessary for it to be wide because in each of its columns I'm going to solve one inequation. So therefore I need actually quite a lot of space. So let me divide it by this line and perhaps by this one here. Oops, I'm sorry, let me do it better, like that. I'm sorry for crudeness of these lines, but it's not possible to do it better using freehand drawing like that. So the first interval is from negative infinity to 0, open at the right hand side. The second one is from 2 to 5, and the last is from 5 to positive infinity. Now the first expression I'm going to replace is the expression the modulus of 4x minus 8. The second one is the modulus of x minus 5. Now here we are going to have the inequation itself. Okay, so this is the preparation phase, and now let's move to the solution. So I'll draw these horizontal lines just for convenience. Now first let me mark the zero of this first modulus expression. So this first modulus expression had the zero of 2. So therefore let me mark it here by this thick line. It means that on one side of this line the expression has one sign, and on the other side of this line it has the other sign. We have to learn what sign it is. So let me choose any number from this interval, for example number 0, and substitute for x. If I do that, I get 4 times 0, which is 0 minus 8 is negative 8. So the expression is negative here, then it has to be positive here and here. Okay, so let me replace it accordingly. So if the interior of the expression, therefore what I mean is the expression 4x minus 8 is negative, then its modulus in this first interval is going to be minus bracket 4x minus 8. And this is it. And it's going to be replaced by itself without any change on the following two columns. So it's like 4x minus 8 and again 4x minus 8. So this is the replacement for the first expression with modulus. As for the second, it has its own 0 at 5. So let me mark it here by a thick boundary. And now let me learn the sign, what the sign of this expression x minus 5 is in these intervals. So the first interval, let me choose any number from within it, number 0 for example. If I substitute 0 here, I get negative 5, so the expression is negative here. It has to be negative also here and has to be positive at the other side of 0. So therefore this is replaced by minus in brackets x minus 5. Here again minus x minus 5, and here just by x minus 5 without any change. Now let me copy the inequation by using this form, but this time I will replace the modulus expressions by the expressions without modulus signs. So on the first interval I have the following. Instead of this I write minus brackets 4x minus 8, okay, like this, minus, and now this minus is here, okay, and now this expression with modulus is replaced by this expression with minus in front. So therefore it's going to be minus minus, which is plus brackets x minus 5, and this has to be less than or equal to 2x plus 8. Okay, so this is the first modulus, the first inequation. The second inequation will be obtained in a very similar way, but this time the first expression is replaced just by 4x minus 8. Now minus, and again minus something, so there is going to be plus x minus 5, which is less than or equal to 2x plus 8. There is no anything necessary to do with this, it's just 2x plus 8. The last interval, we replace the first modulus expression by 4x minus 8 itself, here it is, and minus, and use a pair of brackets to enclose x minus 5. This is less than or equal to 2x plus 8. And these are the inequations we are going to solve separately on each of those intervals. So let us do it for the first interval. I first remove the brackets, so I get minus 4x plus 8 plus x minus 5 is less than or equal to 2x plus 8. Let me continue. Minus 4x plus x is minus 3x. 8 minus 5 is just 3, is less than or equal to 2x plus 8. Now let me rearrange the terms so that x terms are on one side and number terms on the other side. So I add 3x to both sides and remove 8. So what I get is 3 minus 8 is negative 5 on the left hand side, is less than or equal to 2x plus 3x, which is 5x. Now divide by 5, and what we get is negative 1 is less than or equal to x. And we can of course change the sides, but of course we need also to change the sign of the inequality. So what we get is x is greater than or equal to negative 1. So this is the first preliminary solution. I will come back to this in a mo. Just let me do the remaining two columns before that. So on the second interval, on the interval from 2 to 5, let me remove the brackets. So it's 4x minus 8 plus x minus 5 is less than or equal to 2x plus 8. Now combine the terms. 4x plus x is 5x, minus 8 minus 5 is minus 13, is less than or equal to 2x plus 8. Let me now rearrange the terms, so minus 2x from both sides and well, plus 13 at both sides. Perhaps it should work correctly. So if I do that, 5x minus 2x is 3x, is less than or equal to, and here I have to add 8 plus 13. So if I add 8 plus 3, I get 11, plus 10 is 21, and hence if I divide by 3, I get the answer x is less than or equal to 21 divided by 3 is 7. So this is the second preliminary answer, but it's not the final answer. Just wait for a while. The last interval, remove the brackets, 4x minus 8 minus x, and be careful here, plus 5 is less than or equal to 2x plus 8. Now combine the like terms. 4x minus x is 3x, minus 8 plus 5 is minus 3, which is less than or equal to 2x plus 8. Now what we need to subtract 2x, and we need to add 3 to both sides. So what we get finally is x, subtracting 2x we get just x, is less than or equal to, and adding 3 to both sides is you get 11. Okay, so this is the third preliminary answer. I'm saying preliminary, and the reason for that is that we need to do something before concluding what the truth sets on each interval are. And the thing that we need to do is to draw the number line for each case. So this is the number line x, and for each case draw the solution itself and also the interval on which we solve, and then intersect them. Take only those numbers which lie in the interval under consideration. So I will use one color to denote the intervals. This first column represents the solution on the interval from negative infinity to 2. So there is number 2 here, and we have this interval on which we solve this equation. So it's the interval from negative infinity to 2. The second interval is from 2 to 5. So there is 2 here, and we have a closed circle here, to 5, where there is an open circle there. So this is the interval on which we solve it. And the last one is the interval from 5 to positive infinity. Again, it's closed at 5. So it's like that. Now use a different color. Let's use a green one, and depict the solution that we obtained. So here on the first interval we obtained the x values which are greater than or equal to negative 1. So negative 1 is to the left from 2, and we have the numbers which are greater than or equal to this number. Okay. On the second interval, we have numbers which are less than or equal to 7. So 7 is placed somewhere here. So we just take it and represent these numbers by this line. So these are the numbers which are less than or equal to 7. And finally, we have numbers which are less than or equal to 11. So 11 is placed to the right, and the last interval is this interval. Okay. Now, let us take only those values for which we can say that they are on the interval on which we solve the inequation. So we have to intersect these two red and green sets. So the first intersection comprises the numbers which are on this interval and satisfy our solution. So the first truth set is represented by the set of numbers from negative 1 to 2. And at 2 it's open, at negative 1 it's closed. Now the second intersection, well, is representing by the second part of the truth set, which starts at 2 and ends at 5. And at 5 it's open, like that. the final truth set is represented by this. So the third truth set comprises the numbers from 5 to 11 closed at both ends. So these are the truth sets. Now what we need is to write the conclusion. What is the solution to this original inequation? We obtained 3 different solutions on 3 different intervals, and what is left is to add them together, to combine them together to obtain the final answer. So the final truth set is the union of the first truth set, the second truth set, and the third truth set. So if we look at these intervals, the interval from -1 to 2, which is continued here from 2 to 5, which is continued here from 5 to 11, we see that the answer is the interval of numbers from -1 to 11 closed at both ends. This should be the answer to this inequation. So this concludes the method 1. There is infinitely many solutions there in this interval. Now let us look at the second method of solution, which has to do with using technology. So we need to graph both left-hand side and right-hand side of this inequation. So LHS, left-hand side, has the equation y equals, and now use the ABS bracket, and it replaces it, you see, like I did it, 4x minus 8, so this is the first modulus, minus ABS bracket, it replaces it, and here I have x minus 5. Okay, this is the left-hand side of the expression. You see the GeoGebra graphed it here successfully. Now let us do the right-hand side. Y equals, and I write the function 2x plus 8. Here it is, the right-hand side. Now the original inequation demanded that the left-hand side is less than or equal to right-hand side. It means that we are looking for those x values for which the left-hand side is below or at the same height as the right-hand side. So we are looking for those numbers, for those x values for which the left-hand side, the blue curve, is below or at the same height as the red curve representing right-hand side. So you see, here is the first intersection of the curves, there in this point, and the x-coordinate of this point is -1. So it starts at -1, and from -1 up until 11, which is here and corresponds to this intersection of the curves. For those values from -1 to 11, the blue curve is below or at the same height as the red curve. Therefore, we can read out the solution from the graph like that.